Good afternoon, everyone. My name is Ehsan Ababi, and I'm a lecturer at Australian National University at the Center for Public Awareness of Science, CPAS. It's my great pleasure to welcome you all here this afternoon for the Responsible Innovator Lecture Series. Welcome. Before we get started, I would like to acknowledge and celebrate Ngunnawal and Ngambri people on whose land we meet. Today for this lecture, I'm delighted to welcome our distinguished speaker, Professor Katina Michael, who will be talking about designing an implantable device for US soldiers and sharing her amazing experience and insight about DARPA's Adapter program. Of course, cutting edge technologies has its own ethical challenges, and it is hugely topical, and it's a timely address, I believe, Katina. So I'm super excited to hear from you. One of the key things I wanted to quickly let you all know about the lecture series is that it's all about how we run it. It runs fortnightly on Thursday afternoon during the semester. So start of the semester, that means that this is our first lecture series, first part of our lecture series, and you will hear more in 2 weeks on August 11. But the whole idea behind this lecture series is to initiate a new conversation at ANU and beyond around responsibility of innovators as they imagine, design, build and deploy new technologies. So for this purpose, we have invited distinguished innovators and academics from all around the world to share lessons from their own projects and helping us to understand the complexities and the challenges that come with this technology and the ways we can best respond to them. So Katina, I'm extremely grateful that you accepted our invitation to kick off this conversation here at ANU. Katina is a professor at Arizona State University, a senior global futures scientist in the Global Futures Laboratory, and has a joint appointment in the School of the Future of Innovation in Society and the School of Computing and Augmented Intelligence. Katina is a director of the Society Policy Engineering Collective. She's also the founding editor-in-chief of the IEEE Transaction on Technology and Society. So thank you so much, Katina, for joining us. Now, just before I hand over to you, a couple of housekeeping items. First of all, the lecture will be recorded, and the recording will be available on the Responsible Innovation Lab website, that is innovateresponsibly.org. So if you want to share the recording later on, you are more than welcome to go to the website and share it with your network. There is an opportunity for you to ask questions in the Q&A session. And so if you have any question from Katina about the talk, please type your question in the function below your page. And when it comes to Q&A session, you can always unmute yourself and ask your question. That's it all from me. Without further ado, I hand over to you, Katina.
It's great to be with everyone this afternoon. Sunny day in Australia, at least on the southeast coast.
No, it is. It is.
No, it is. Yes. After all that rain. Yeah. It's wonderful, first of all, that ANU have begun this initiative into responsible innovation. Dr. Nabavi, congratulations for setting up this group and this team. We now have several journals of responsible innovation. ACM just emailed me yesterday saying we're looking for articles. This is ACM, the ACM. The Journal of Responsible Innovation was actually started by David Guston, my director or former director at Arizona State University, and taken over by Eric Fisher, who is one of my peers at the School for the Future of Innovation in Society. A lot of the work on ELSI and responsible innovation came from this school when it was a lab in Washington, DC. It was part of the CSPO think tank, the Consortium for Science, Policy and Outcomes. This all came into fruition from the Human Genome Project, amazingly, and it's been extended now to incorporate technology, not just science. and it is all about policy, but it's all about understanding all these various perspectives as they come together. And today I'll be presenting the complexity of thinking about responsible innovation with regards to the design of an implantable therapeutic device for US soldiers. Note, DARPA don't like the idea of the word enhancement. They talk about therapeutics or health or well-being. So this is not an implant for enhancement. This is about well-being. And there is a distinction here, at least in definition and literature. So I'm very honored to have been given this platform, and I hope I can share with you some of my lived experience and qualifications with respect to this particular project I'm on. As a disclaimer, it's really important, I'm not an employee of the Department of Defense, nor am I an employee of the US government. The views presented are not the views of DARPA, DoD, or the US government. Further, the activities are not endorsed, sponsored, or promoted by DARPA, DoD, or the US government. These are purely my own findings and research thoughts. So let us begin. What is Adapter supposed to achieve, right? Think of the human body and think of an implantable device within the human body. Adapter stands for the Advanced Acclimation and Protection Tool for Environmental Readiness. It's a program that's located within the DARPA Biological Technologies Office, BTO. Adapter aims to develop a travel adapter for the human body. I literally want you to think about a plug in the wall that you put into a socket, right? But think about one for the human body that's wireless. It's an implantable, so it is actually a device, like an RFID device that can go in to the tricep, or it's ingestible, I swallow it, right? And it contains a bioelectronic carrier that has inside it cellular factories and compounds, which are therapies, to be released upon secure external activation. So I may take my mobile phone, I may put it against my arm and trigger the device to come alive and potentially emit these therapies in the body for two main reasons. So imagine a soldier on deployment having the command and control to trigger a release of therapies to prevent particular conditions in their own body. It's like, oh, I know I'm about to be deployed overseas. Okay, this has to kick in this cycle according to the app on my phone. The system is designed to either entrain the sleep cycle, halving the time to reestablish normal sleep after a disruption. For example, from jet lag, I'm traveling to another time zone, or I'm changing shifts as a soldier from night shift to day shift and afternoon shift. And again, every 2 weeks, I'm moving and shifting between same location, but different times of the day that I'm supposed to be awake and working. And it's also being used for travelers' diarrhea, which is a common phenomenon for people when they move from one location to the other. You step onto another country's soil, you eat something from a stand or from the hotel or from an army base, and for whatever reason, you end up with travelers' diarrhea. And 5 bacterial sources are usually responsible for that circumstance. So consider it a remote control capability to wellness and recovery. So, oh, my tummy feels sick, I'm going to emit those therapies into the body. Or I know I'm traveling somewhere or I'm changing shifts. Again, I look at the clock and understand how my body will respond to the different times. So Adapter is the way, or our way, to physically interface with the human body. It's a type of wireless living pharmacy via an implantable device that attempts to control the body's circadian clock, aiding to regulate cycles by providing accurate diagnostics and response mechanisms. Now, our body has a number of clocks. Let's call it the circadian rhythm. And these are calibrated. Often when people move to a different country or are constant road warriors and they're flying from one country to the other, what happens is they put on weight. It's not because they're eating more, it's because their body doesn't really know when to eat. Breakfast, lunch, and dinner, where I am currently, is very different to breakfast, lunch, and dinner when I travel to Singapore, if I travel to the Middle East, or I travel to New York. And this is what this is supposed to help with. It's the recalibration and halving that recovery time. Now, the concept is incredibly novel, but we are increasingly, as our opening, Dr. Nabavi told us in his opening remarks, this is becoming increasingly topical. Many of you would have heard about the Synchron Device, okay? It's more a brain-to-computer interface developed by Thomas Oxley and his team from the University of Melbourne originally. I remember reaching out to Tom in 2016 to come and give a talk on his research. I have been surprised at the speed of deployment of this Synchron device, but also on Elon Musk's journey with Neuralink. But there are now 5 or 6 of these sort of biomedical device companies that are beginning to spur on. So I don't think adapter is a far-fetched idea, but for the vast majority of us, we're not waking up in the morning and thinking we're going to be implanted with a device. We have had these discussions in the past. In 2010, at the IEEE International Symposium on Technology and Society that I chaired in the University of Wollongong, we had a meeting where we brought in implantees from all over the world to discuss various aspects of what this might mean in a non-medical capacity. For example, paying for food, downloading an item with the scan of my wrist, perhaps, which has an implant on the inside, and all the ethical implications that come with that as society changes, the way that they adopt technology and the form factors which technology comes into. So when I talk to DARPA and that, I say, really, this is going to just stay within the military? What do we really know about these military concoctions? We know that these have very much commercial value. They are test beds within the military, perhaps in the context of having a great vast number of people to test these applications and technologies and systems on. But in this case, we're not asking a US soldier, for instance, to take a vaccination. And many of us know already that the Defense Forces sometimes enforce up to 14 or 15 vaccinations on the first day of arrival. You want to protect and prevent illness in your armed forces. So there is a mass requirement for vaccination. Well, imagine you turned up one day as a US soldier for your duty, and you were told, by the way, now we have developed this new novel technology that will help you in your day-to-day work. And that technology is an implant. This raises a whole number of questions in our minds. And these are the things that I want to inspire in you today as you think about what is this adapter thing we're talking about? What is this implantable device for military personnel on deployment or as they go about their work, and shift lag and jet lag, and perhaps falling victim to travelers' diarrhea, as often is the case, or the 2-week recovery sometimes with bad cases. So I want to start thinking in the spirit of this talk in the abstract. I talked about scenarios. I talked about various thought experiments. I want you to think about a potentiality. In the next 5 years, all US warfighters may well be implanted with some kind of device that is aiding them, not purely for identification, but perhaps for, as we said, recovering from very minor illnesses that can be done in the field, doesn't have to take the soldier away and placed in quarantine, and also, for example, in these jet lag and shift lag situations. Now, the device, as it's been depicted online about 12 months ago, looks something like this. And I just want to note, while I can't tell you technical things about the project, I can certainly share with you what is in the public domain. So I want you to start thinking about operational scenarios for these implantables, which are incredibly gaining momentum. And this is with the rapid growth that we're seeing in the prosthetic market, even insulin pumps, even biomedical brain implants and pacemakers. And citizenry now have become accustomed to this idea of implants. But are we ready? How do we know what society thinks about something that's happening in a defense agency or an armed force? Do we reach out to society to raise awareness? Do we hold specialist panels in order to gain an understanding of the issues that might arise between those who have been implanted and those who are not? Remember, soldiers often go home during a holiday period to their families. And if they're wearing this device, may they get particular questions from general members of society. Also, the laws and regulation around military personnel are quite different in some circumstances and contexts to those other regulations and laws in the civilian world. But a US soldier doesn't suddenly turn off his US military identity when he goes or she goes back into civil society. The implant is not simply an eject button, which allows people to remove the device so that it is no longer triggerable. It is no longer can be used in any particular way. And this can provide a mismatch. So as patients, carers, doctors, nurses, engineers, counselors, and teachers have begun to be educated about these next generation devices, a whole economic infrastructure is growing there in the biomedical device space. In fact, we were very happy to hear the news recently. A $3 million grant led by Professor Leila Ladani at ASU was actually given to us. I'm on that project with her and the representative of the Mayo Clinic near Arizona that is looking at the potential biomedical device human interfaces in addition to the ethical, legal, and social implications. This is real, everyone. This is sometimes the difficulty about projecting forward to technologies that we believe are still far away when we are being funded by the National Science Foundation, particularly for scholarships of students. So any students out there wishing to do a PhD at Arizona State University, anywhere in the biomedical engineering or engineering realm, we'd love to hear from you as we are seeking students to begin at the beginning of next year. And we are looking in particular for diversity, males, females, others, and so forth. So we are now increasingly looking at this DIY generation that is saying, hang on, if you implant me, I can tinker with this device and I can do with it what I will. What is to stop armed personnel from tinkering with their implantables, hacking into their implantables, and fine-tuning them? We already know something amazing about insulin pumps. In recognized research in the literature, these are not as functional as we believe. It is not simply one size fits all. Just because I release therapies in the body this way in one soldier, it doesn't mean that the effect will be the same on another soldier. And this is where customizability comes into the equation. And so increasingly what we're seeing is that individuals know their bodies better than anyone else, and the effectiveness of how we deploy these technologies in our own selves may well be enhanced by the knowledge we have of our own self, this intimate knowledge of when we feel okay, when we feel great, and when recovery is best. But we've seen companies out there like the Vivo Key that have considered how to tether edge devices like mobile phones and other devices, perhaps on a lamppost, with an implantable in a human being through a smartphone or through some kind of other device. So it's no surprise to me that DARPA actually got in contact and wished to take on some of my skills in order to unravel what this might mean for society in the future. And I was not alone, but I'll talk to you about that in a moment. So according to DARPA, the Adapter program will develop a travel adapter for the human body, as we said, and it will allow for the therapeutic cellular factories and biomolecules, which will provide the warfighter control over their own physiology, quote unquote, friends. Adapter is multi-application and multifunctional. It uses an integrated system to house a variety of biosensors that will be diagnostic and interventionist, disrupting the typical medical supply chain. So instead of going to a doctor, then to a pharmacy, the pharmacy is within you. It will provide just-in-time antibiotic production and will be wholly embedded and performed in vivo. Adapter will allow for toxin removal, for example, that causes diarrhea, from ingested resources, and will provide the soldier on deployment with the ability to quickly acclimatize due to time zone differences the body is unmistakably exposed to after long-haul travel, so shift lag, jet lag, and so forth. So the whole point of Adapter is to overcome human physiological limitations during active operational service. And this is a depiction of what one of these look like. Remember, there is an implantable device and there is one that you ingest, you swallow, like that swallowable pill that Motorola X had developed for security purposes some years ago. So Adapter is not about altering the genetics of the human body, but working with the body to provide transient enhancement and extension of warfighter readiness. As you can see in this figure of the way that the device works. So you implant someone, the armband on the outside is triggerable because it's in proximity with the chip. It's the closest to the tricep area. And then I may take my handset and trigger it externally further. And we discussed the form factors regarding the size of some of the triceps of some of the armed forces. And this is why it needs to be close to the surface so that it can have that sort of 10 centimeter proximity, of which most RFID and other types of devices can communicate. So we see how this works in a proof of concept using an edge device, the external hub. The external hub is the armband, interfacing with the normalizing timing of rhythms across internal networks of circadian clocks. That's called N-train implant. Each transponder implant has a unique ID that will come with enough storage capacity to contain an encryption key for secure data transfer. It is believed that the implant will be embedded during an outpatient procedure into the subdermal layer, and the insertion site will be the triceps of the individual. The chip will be triggerable by the battery-powered hub attached to an external form factor, like wearing an armband, right? A wearable armband, or even a luggable smartphone. The hub will receive and transmit signals while tethered to a smartphone using a dedicated app. So imagine your mobile to have a dedicated app that allowed you to control the emission of these cellular therapies into the body. Now, a bit about DARPA's methodology. It's really important to know that maybe about 6-7 years ago, DARPA was caught out. A lot of the flack that they copped was regarding not actually being aware, or at least pouring in some support and management to what's known as ELSI, the ethical, legal, social implications. Interestingly, responsible innovators and ELSI panelists are not brought in at the conception stage. In fact, it was many months after the fact that people like myself were brought in to participate in a panel. This, to me, is actually the beginning of an issue. I won't overstate it, because I have to say DARPA has been willing to listen to everything I have shared with them regarding concerns and also potential benefits. But we do have to think about something. When we say we are responsible innovators, the question is whether we're responsible after the fact or at the conception of the idea. Many of us might identify risks at the very beginning of a new invention that we are thinking about in our heads. Like, imagine I could create a patent to actually do this. Now, I've got to tell you folks, I've had many such ideas because of my research area, now 20 years in the implantable space, if not more, beginning with my PhD in 1997. So that the question then becomes, everything I dream up of, should I just then go and, develop a patent? Interestingly, a lot of my IEEE research has actually been cited in patents, but I, for one, have not sought patent approval or filed for patents with regards to the things that I conceive of or dream of, knowing what I know about implantables. So the question is whether you start with RRI, responsible research and innovation, before the fact, as a rubric, as an approach, as a philosophy, before you start to think about the potential of new technologies. The other thing I want to say is, can you prejudge ethics? I can perhaps say, oh, this is a bad scenario. This is not good for society. But what is my evidence? Can I really prejudge what will happen when a device like the N-train adapter is deployed into the US military and potentially commercially beyond? I can, to an extent, unravel the major issues that may come to the fore, things that I can anticipate, things that are intended, and there are obviously things that are unknown, as we've said before in the past. So what do? Well, we use the tools and techniques and methods that we have at our disposal to start to explore the question in more depth. So if I know that I'm not going to stop a train going at 110 kilometers, do I simply move out of the way and that is the right thing to do? Or do I say, now, look, the train is coming at this velocity, what can I do to prevent it from squashing everybody in its path? And in this instance, what I'm trying to say is it better if we disagree with a potential invention to just say we have no participation in its invention, when we know it will likely happen with or without us? The best advice I can give is that you share as much as you can, and those who will listen will listen. It's very encouraging to me that agencies like DARPA are beginning to see the value after many years of investing in these groups, although I'm not a paid individual, nor is the panel at large, but at least we're given space at the table when the majority of the discussion has been technical and not socio-technical. it has really been about the fine tunings of the technicalities of how something can actually work and reliably and be available, rather than those other issues like ethics. It's great to see in a day's workshop, twice a year at least, that these things are being discussed and taken seriously. In fact, we were given a whole day at a workshop to deliver part of what you'll see today. So the ELSI panel was formed post the tender, where university participants had already been announced. But at least they considered ELSI, as I said, and they did provide us with non-disclosure and other agreements we had to sign for up to 5 years. Now, the reader must remember, again, DARPA is about blue sky projects, and this definitely is one of them. An ELSI panel has been composed mainly of interdisciplinary/transdisciplinary academics with different strengths in ethics, law, and social implications. ELSI has been previously applied in the fields of genomics, forensics, and nanotechnology, and as I said, was really born out of the work from the Human Genome Project. James Watson is credited with framing and naming this notion of ELSI, which is very closely aligned to RRI. In Europe, people talk about ELSA instead of the implications of ethics, law, and society or social. They're talking about aspects. And so often with regards to implications, we know that they're either positive or negative, whereas aspects allow us to explore the dimensions further. And as RRI was born out of research in Europe, you then start to see this continuation of the notion of RRI. So I kind of synonymize ELSI with North America and RRI with Europe, although many people in my school at the Future of Innovation in Society work with many Europeans as well. But if you look up the work of David Gustin, for example, Eric Fisher, Bob Cook-Deegan, Mahmoud Farouk, Cynthia Celine, these are the wonderful experts in this space within my school. Now, RRI, in a basic definition, and here Dr. Nabavi would know a lot more than I do, but anticipate, reflect, engage, and act, the short acronym of AREA. And interestingly, many people have criticized RRI as a way to perform ethics washing or legal washing or regulatory washing or societal washing, like is a panel in existence to be like a scapegoat through the design process. So I want to design something. Hey, I should bring on some privacy specialists. I should bring on some legal specialists and some ethical specialists and still do whatever I want to do. And I could name quite a few high-profile cases where this has happened. And the result has been a breakdown in communication between the panelists that are responsible for ELSI and its sharing in these particular technical projects. And they literally fall apart. You usually see the privacy scholars that don't allow ethics washing to occur or privacy by design washing to occur. And so what I would suggest, one way to circumvent this is to continue to document. For me, the process of design in ethics, law, and society is just as magnificent as the process of documentation and creating a historical file in the filing of a patent. When you go to file a patent, they ask for your technical file and your historical file. They want to see that your technology was not developed in a garage, that you actually did ask people what they thought, and that this has been documented over many months or years or weeks, however long that period might be. But I would say if you're very serious about responsible innovation, start to prove it. We can all say, today I feel like having my responsible innovation hat on, and tomorrow, well, I think I'll have my technical hat on and forget about talking about law and society and ethics. If I was to talk to the whole technical community before me today, I would say that this will be embedded in your research and in your practice. Gone are the days we can simply bolt on these values into a research design or a design of a product and get away with it. You can't bolt in. What we're talking about is embedding from the outside of the design process, beginning with the problem definition. And here I would say is the only failing that we've seen because we weren't brought in right at the beginning. It was a few months later after the horse had bolted. So some fundamental definitions here. I always go back to basics. I always look at synonyms, and I always look at examples. And I would encourage you in your research to start with those fundamental definitions before even going into some more of that complexity. So what is ethics? You know, I struggle to find any papers online that actually describe these various definitions within the ELSI context, although we've been talking ELSI now since 1988. So I would encourage you in your own research, start simple, define, look at synonyms, look at examples. Which ones can you point to? So ethics, for those who are unaware, but you shouldn't be as trained engineers, given Engineering Australia's participation and also the Australian Computer Society. If you're computational people, it's the moral principles that govern a person's behavior or the conducting of an activity. We're talking here about morals, moral codes, morality, moral principles, values. That word values-based design that emanated from Bto Friedman at the University of Washington when she spoke about value-sensitive design. But in this ELSI thing, values comes up again and again. What values are we talking about? And in many of the researchers' profiles we'll see online, you know, you can count up to about 80 values that have been identified, privacy and security and rights, examples of some of these. Rules of conduct, behavior, and here are some examples. And I have to say, based on recommendations we made in the group of 4, that the notion of an ethics hotline was established for us to be able to empower the engineers working on this project if they had any concerns about any aspect of the project. This is a sensitive issue, and it requires young people who are perhaps in the postdoc level who may have concerns. Do they go to their boss, who may be the research director who gained money for this particular grant or this particular project? And then you have all of these dynamics. So can people actually raise their concerns, and can the concerns be addressed? We even had a novel episode during one of our workshops where we were able to meet one-on-one with technical engineers. So the ELSI panelists were pretty much spinning round and round networking, but at the same time talking about the different ELSI perspectives with the technical community that is noted as being interdisciplinary. Ethics, as we covered here, the law here, the system of rules which a particular country or community recognizes regulating the actions of its members and which it may enforce by the imposition of penalties. What are we talking about here? Well, different regulations, different rules, different soft laws like standards. Technical standards increasingly are now being considered a soft law because technology is really undergoing what's called the pacing problem. We're developing these new, amazing, almost far-fetched ideas. In the form, it's possible, but we lag so far behind in terms of the support infrastructure there through laws and regulations and guidelines and codes. So this is something to think about. Are we talking at the international level to govern in the terms of governance of a legal kind of right? Supranational, as in the case of the European Union that goes beyond one state border? Is it federal or constitutional? Is it state, local, municipal? Do we think about things like human rights as defined in so many different kinds of rights through the United Nations and others? Are we talking tech-specific, tech-neutral? And what kinds of laws may we require in the future for these kinds of technologies? Does anything really change? And are we going to wait for case law to determine that? Usually that is how the law works. On the social side, we're talking about relating to society or its organization. Think about community, think about groups, the collective, what's popular out there, the civil, the civic, the public, the organized. And here I do want to stress on that word public. We have created a new degree at Arizona State University. It's a Master's of Science in Public Interest Technology. Public interest technology has a lot to do with responsible research and innovation and ELSI. Why are we building the technologies that we are building? How will they serve the public? How will they serve the US soldiers in this case? Here we can look at different forms of organizations like schools, clubs, faith-based organizations, at the local, regional, national, and international level. We're talking about dignity, freedom, and autonomy. These are three major terms that you're going to find in human rights literature. And if we put these together, we sort of have this kind of presentation. You can smack bang in the middle say, well, we're doing this with a technology in mind, but really it's something a bit different here. It's the intersection of the ethics, the law, and the society. And you can only achieve this when you reach out to different stakeholder types. And while I don't have a presentation map here to show you all the different members of society, we are talking about industry, the government sector, the third sector, such as non-government organizations and not-for-profits. We're talking about the media. We're talking about civil society, young people, children, elderly, those in the workforce, those who are in underrepresented minorities, those who have different kinds of stakeholder engagement. And when we ask different stakeholders in society, what are the ethical issues with a thing like this called an implantable device for US soldiers, they'll respond in a different way. Again, I want you to think about what you are thinking about while I talk about this implantable device for US warfighters. The other question is, do we go beyond the socio-technical system to include aliens, those who are outside the US warfighter ecosystem? And so this is when open systems and closed systems and campus-based systems start to enter the discussion of socio-technical design. And on the next slide, I demonstrate this to you. I've put in the technical, right? Because when you look at socio-technical design, you're almost saying we need the values in the socio-technical design process. And what you're doing is bringing these perspectives together to denote an environment, which is where the rules and regulations reside, and the laws and the guidelines on how to use the technology. And then within the system, perhaps how it is deployed among different members of the armed forces, and what rights people have with respect to whether to adopt or not adopt. And that's very important when we're starting to look at the military-industrial complex, which is very, very complex to study. Very quickly here, I wanted to say a big thank you to my fellow ELSI panelists, Sarah Girk, Maxwell Melman, and Matthew Winiar. And we all have very different skill sets. Sarah is a lawyer. Max is an ethicist in the law and medicine field. Matthew Winiar is a medical physician, and he also runs the Center for Bioethics and Humanities at the University of Colorado, and myself in computing and also the School for the Future of Innovation. We can see 2 males, 2 females, but the criteria for selecting us is quite unknown, save for what I guess is our published works in the field dating back for 20 years and more. Interestingly, what DARPA call interdisciplinary is not really interdisciplinary. It's all these different technical communities that have come together. In the projects themselves, in the original booklet, I did a bit of a summation. 86% of the individuals were male and 14% were female. And I haven't looked at our mix today of listeners, but I imagine we are pretty much the same as that, although I know there are different profiles in different universities, and I encourage more representation of women into our programs. It's very important, because otherwise we're building products, I would say almost irresponsibly, if we are not being inclusive in the design process of various representations. I want you to look on the left to see which were the universities, and there are 3 major projects within this adapter, all of which approach the technical view in a different way. For example, an ingestible pill versus an implantable. That's just 2 form factors. I haven't really said anything technical there, but you can see as we go down the list, these are the typical culprits in the US ecosystem of academia: Northwestern Uni, Rice University, the University of Minnesota, Carnegie Mellon, University of Utah, excuse me, MIT, Stanford University, and an interesting one that's not really a university, not at all. It's Blackrock Microsystems, which are famous for investing in a whole bunch of various blue sky projects. And I have to say, I've been very enamored by a number of people in these technical interdisciplinary teams. They're not truly interdisciplinary or transdisciplinary. They're literally from the engineering, right, field, the STEM field. But I have been amazed by the questions that the young people within these groups have asked. When I say young, I mean anyone between the ages of 20 and 30 that is in that stage of their early career research, and loved the fact that a lot of attention and respect has been given to these ethics discussions. So how do you navigate this space? You know, I wake up in the morning and I think about a question and I think, hey, that's a great invention. I want to look up on the uspto.gov if anyone has created this patent. And I find nothing. What do? Well, I begin with thought experiments. I even, to embody the thought experiment, might ask a number of students or staff or family, for that matter, to go through a role play. And then I reflect. So I think about something. How would it work in the real world? And then I reflect on that practice. And a thought experiment goes from the thought in the mind to an embodiment where people are together and moving and interacting. Something magical happens because those big barriers that may exist come to the fore and you can't really turn a blind eye to them. When I think about things, I don't go through a walkthrough in stages, but when I act it out, I do, in fact, see the real world context before me. So I know this sounds crazy, and I know we're not actors, but increasingly I tell my students and fellow industry partners, let's have a role play. And sometimes that just incredibly releases those issues to come to the fore. And either you record the role play, I would say do spontaneous role plays. Don't sit there writing scripts, but have something to trigger the role play. Choose the 3 or 4 or 5 people, sometimes even one. I remember doing something like this in a live audience capacity when we're looking at autonomous vehicles. And I had an experience where I got into an autonomous vehicle and didn't know where the handle was to open the door. This can also happen in a Tesla because the handles are not in the normal places that we see. And when you're in an autonomous vehicle, that's a third party. Of course, there was a driver. I'm just looking for that exit, but then I use that as inspiration for a real role play in a real live audience. And I said, right, you're in an autonomous vehicle. The car's not opening. You don't know where the doors are, or it's locked you in. What do you do? And it was fascinating to see that played out. We actually have footage of that on LinkedIn or somewhere on the web, showing what the person who's an informed individual about autonomous vehicles actually acted out. Imagine doing that about implant scenarios. I'll give you some examples of role plays I concocted for our workshop. A soldier refuses the implant upon enlistment. What do? They say they have their soldier rights, but they've got civilian rights too. An implant doesn't seem to be working. I'm more sleep deprived than ever before. I want to throw that implant out, but it's injected into my body. I keep getting people asking me what the armband I'm wearing is. Can I take it off when I'm at home? Very simple question. It just feels like it's an example scenario. So there's scenarios that we pose. We actually posed 3 in a one-day workshop recently on May the 5th. We then had questions regarding the scenarios. We collected responses from about 100 people in the room. We had a discussion, a live discussion, and then we reflected. So you can take these different approaches to actually applying and not just simply sitting there thinking, now what will this mean for society? This has to be grounded. This has to be documented within your socio-technical systems design work. So this was our scenario. This was our third one. I'm Captain Roger Jones, and I'm a Navy SEAL who recently was deployed. I was given an implantable device to help with my jet lag and shift lag during deployment. I use my cell phone to let the device know when I will be asleep and when I'm going to be awake. However, lately, I've been feeling tired all the time. That was one of my role play scenarios, actually. So my phone has been doing weird things as well. I think it might have a virus. How can I make sure I'm not being hacked by the enemy? This is a real potentiality. We've asked a lot of questions regarding security of the technical personnel on these projects. These were our questions. What steps should Captain Jones take to make sure that the device is functioning properly? Who should be contacted about getting access to a log of communications? Is there an IT helpline for this implant? What should be the regulatory status of the device? Has it been approved by the FDA or not? Can Captain Jones keep the device active when he's not deployed? For example, I like feeling this when I'm at home with my family and then I go on a holiday. Can I actually use what the military gave me as an app when I'm on a holiday and not during military service? So these were some of the things that we discussed, and we created these charts of divergence and convergence to bring the responses from the floor together. It was incredibly effective, though we didn't have that much time for the breakouts and so forth. We did dedicate about 10 minutes to each of the questions, which was roughly 40 minutes. The end-to-end activity took about an hour each. So I'm going to skip these questions now and show you one of the preliminary examples of a socio-technical system that has ELSI at its core, what it looks like with respect to the implants. And to finish off here, because we are at the end of time almost, I want to leave time for questions. These are some of the issues that were raised during different parts of the aspects. So ethical, we interpret it as values, because most people talked about values, the personal versus the military, the access to the data versus a kill switch. And these also were linked to the technical questions. Is this an autonomous device? Do I have control over it? Is it triggerable remotely by a commander or a doctor at the base? The legal side, what are the soldiers' rights versus the citizen rights? Standards and guidelines, which are very important, and then public awareness, which was something that's, to me, increasingly important. As things become more and more black box, how do we inform the public of what is happening in our laboratories? It's not that we want to stop what's happening in the laboratories. That's nothing to do with it. It's about raising awareness and ensuring we are going through the right design processes with ethics at heart. As a closing remark, I just want to say, we did raise the question, we can do these activities with different stakeholders. We can ask different questions of medical doctors, of legal representatives, of lawyers, in different courts. In the end, has anyone asked the US warfighter? And as silly as this might seem, that was a very big question. Actually, where were the surveys? Who said that they wanted it? And this is one of the fundamental questions. And although much of the response had to do with, well, most Navy SEALs would love this. They love trialing new tech. I think that's a little bit of the novelty effect, which is like, oh yeah, give me this technology. I'd love to wear it like my infrared goggles and everything else that I have on my body with the GPS enabled XYZ and the things that are perhaps, emerging in terms of self-healing band-aids and other things. But I'm more circumspect. We do have to ask the fighter, the US warfighter, and consult with them. The whole idea is to consult and cooperate and work together in the design process to allow for participatory design. This is not about excluding the US warfighter, telling them what is good for them and then deploying. This is about bringing their brains into the design process and saying, here are my limits. Here is where I would accept this. Yes, swallowable, injectable, perhaps not. So the fundamental values that we believe are in the personnel have to do with autonomy, going back to that human rights literature, security, as we saw through many of the scenarios we posed, safety, privacy, trust, and what we thought was the biggest injection we could make to this design process is a values-based design, which we believed was entirely absent because all the engineers were really interested in about and still are interested about is not values. It's all about getting a functional technology to work and recuperating the investment that DARPA has made in those organizations. So with that, I stop sharing and open to questions with 8 minutes to go.